This video lesson is going to be on solving proportions. So we're going to be dealing with two fractions or two proportions being set equal to each other, and ultimately our goal is going to be to find a value for x, or whatever variable we may have been given. The most important thing that I need you to take away from this screen is that I cannot have a restriction as my answer or my solution. And a restriction is a number that makes my denominator equal to 0. And if it makes one of the proportions have a denominator that it is 0, it does not count as a solution. And we're going to see an example of that in a little bit. So here's the first example that we've got. And you'll notice that these two fractions are as simplified as they can be. So I'm going to multiply both numerator and denominator on both sides of this equation so that I can get rid of the fact that I'm dealing with fractions. So I'm going to have 3 times the quantity x plus 7, and that's going to be equal to 12 times x. I'm going to distribute here, so I have 3x plus 21 is equal to 12x. Subtracting 3x from both sides will give me 21 is equal to 9x. Dividing by 9, this is a fraction that I can simplify. So I'm going to have that x is equal to 7 over 3. So now with this value of 7 over 3, I need to now go and make sure that this value does not set either of these denominators equal to 0. So if you look at our first fraction, the value of x itself is 7/3. That's not going to make this denominator equal to 0, so I'm okay in that case. Substituting x into the second fraction, 7/3 plus 7 also does not give us a denominator that's equal to 0. So that answer, in our case, 7/3, we've checked it. It does not make either denominator equal to 0, so we're good with that answer. Moving on to our second equation, or our second proportion that we're dealing with here. I have a linear denominator in the first fraction and a quadratic in the second fraction. Both of these are as simplified as they can be. There's nothing I can cancel out here. So I'm going to do my cross multiplication. So I have 5 multiplied by the quantity x squared minus 1. And that's going to be equal to 15. Pen doesn't want to agree with me. Times 2x minus 2. And I'm going to distribute. So I'm going to have that 5x squared minus 5 is equal to 30x minus 30. Now, because this is a quadratic, and we already know how to solve a quadratic, I know that this has to ultimately be equal to 0. Since I want that x squared term to be positive, I'm going to leave this over here. So I'm going to have 5x squared subtracting 30x over gives me minus 30x. And then adding 30 would make this plus 25, and that's going to be equal to 0. This is a quadratic that I can factor very quickly, so that's how I'm going to solve this one. I have to take 5 as my greatest common factor and divide that out, so I'm going to have x squared minus 6x plus 5. And that's going to be equal to 0. This x squared minus 6x plus 5 I can factor quickly into if I can get the pen to work, x minus 5, x minus 1. Setting both of my factors of x minus 5 and x minus 1 equal to 0. This would give me an x value of 5. X minus 1 being equal to 0 would give me an x value of 1. So I need to check these two solutions in the denominator. So if I start with 5, 2 times 5 is 10 minus 2. That is not equal to 0, so far 5 is okay. 5 squared gives me 21. Minus 1 is still not equal to 0, so I'm okay with 5. Now if you check 1, substituting in 1 for the x value in both denominators would give me 2 times 1, which is 2, minus 2 is 0. That automatically tells me that x equals 1 is not a solution because it creates a denominator that's equal to 0. So I have 2 more examples we're going to work through. In this case, now I'm giving you a proportion that deals with a radical. You could translate the radical into a fractional exponent and solve from there, but because this is a square root and I can very easily undo square roots by squaring, I'm going to leave it as is. So I'm going to say that I need to multiply both sides here by 8. If my pen would work. That's going to cancel out 8 in the denominator here. So I'm going to have that the square root of x is equal to 16. And in order for me to cancel out the square root here, I need to take this whole piece and square it, which means I need to do the same thing to 16. Squaring a square root leaves me with just plain x. 16 squared gets me 256. And the reason that this is only positive 256 is we know that I cannot take the square root of a negative number that's resulting in a positive answer. There is no imaginary numbers located in my original problem, so the only value I can take in this case is positive 256. Last question. Now you'll notice that there is a square root in the numerator and a square root in the denominator. So in this case, when I cross multiply here, I'm going to have the square root of x times the square root of x. That's going to be equal to 6 times 3x minus 5. So the square root of x times the square root of x is like taking the square root of x and squaring it, because I have 2 of the same thing. In this case, it's the square root of x. And I'm going to distribute the 6 over here, so I have 18x minus 30. The square root of x squared leaves me with x. The computer is not behaving with me right now. All right, that's better. So the square root of x squared leaves me with x. The right-hand side of the equation hasn't changed. So I'm going to subtract 18x. That gives me negative 17x is equal to negative 30. Dividing by negative 17, I'm left that with x being a value of 30 over 17. And because I know that the square root of 30 over 17 is going to be a positive answer, that tells me that that denominator is still positive, not equal to 0. So I am good with the answer of 30 over 17.